Sharing good design, Millau Viaduct. One of the tallest cable-stayed bridges in the world, the Millau Viaduct in France was built to link the Paris to Mediterranean road. It is renowned for its magnificent architectural design and superior engineering, and it spans the Tarn River Valley. The bridge is an amazing piece of architecture because it drastically cuts travel times, enhances traffic flow, and harmoniously integrates with the surroundings. Structural efficiency and aesthetic appeal. This is why it resembles good design. Long spans between pylons are possible with the cable stay design, which minimizes the impact on the surrounding terrain and the quantity of supports required. The bridge appears sleek and beautiful and fits in perfectly with the natural surroundings. Its elegant appearance is enhanced by the use of high-strength materials in its thin tapering towers. Engineering innovation and environmental considerations. Modern engineering methods and materials such as high-performance steel and concrete were used in the construction of the Millau Viaduct to guarantee stability and longevity. By minimizing the amount of support structure in the valley and protecting the natural ecosystem and terrain, the design reduces environmental disturbances. Functionality. The bridge shortens travel times and boosts economic efficiency by greatly increasing connectivity and traffic flow between northern and southern France. The components come together to create the Millau Viaduct, which is a marvel of engineering and architecture in addition to being a useful piece of infrastructure. Who created the design and why? French structural engineer Michel Berlacheux and British architect Norman Foster designed the Millau Viaduct. The structural engineering work was done by Michel Berlacheux, who made sure the bridge could cross the Tarn River Valley with the least amount of supports possible while yet being strong and stable. Renowned for his avant-garde architectural ideas, Norman Foster concentrated on the bridge's aesthetics and harmony with the surrounding environment. Together, they set out to design a structure that was not only aesthetically pleasing and ecologically conscious, but also practical and efficient. As a consequence, we have a bridge that is a monument to contemporary engineering and design that improves connectivity and travel efficiency. What was their background and what disciplines, if any, were they drawing from? Renowned French structural engineer Michel Berlacheux has a background in civil engineering at two of the most prominent engineering schools in France, where he received his degree. Michel has a great deal of expertise planning and building bridges. He has applied his knowledge of structural engineering, civil engineering, and materials science to a number of noteworthy projects. His knowledge in these fields enabled him to create creative fixes for long-span bridges that guarantee their strength and aesthetic appeal. Michel uses his expertise in structural engineering to build the Millau Viaduct, which ensures stability and leaves as little of an environmental impact as possible while spanning the wide Tarn River Valley with few supports. Key factors. Utilizing advanced computer modeling and structural analysis methods, he made sure the bridge could support a range of loads and stresses such as traffic and wind. High-strength steel and concrete were used as the high-performance materials to provide the required strength and durability while maintaining the structure's relatively lightweight. Longer spans between pylons were made possible by the cable stay design, which decreased the number of supports required and lessened the landscape's impact. Because of the bridge's height and exposure, aerodynamic characteristics were included in the design to minimize wind resistance and guarantee stability. By carefully arranging the locations of pylons and employing building techniques that lessened the impact on the surrounding terrain, efforts were taken to minimize environmental damage. Values. Innovation. The bridge's design and construction pushed the limits of what is feasible for bridge building by showcasing state-of-the-art engineering and architectural approaches. Aesthetic harmony. By blending in perfectly with the surrounding environment, the bridge demonstrates a dedication to building structures that enhance rather than overpower their surroundings. Efficiency. The viaduct exemplifies the importance of efficiency and pragmatism in infrastructure planning by optimizing transit lines and cutting down on travel times. Environmental sensitivity. To demonstrate respect for the natural environment, efforts were taken to reduce the environmental impact during construction. Engineering excellence. The high construction standards and painstaking attention to detail demonstrate a commitment to excellence and quality in engineering. Perspectives included engineers, architects, environmental planners. Perspective left out local communities, cultural heritage, and wider public.